Good morning students. It's great to meet you again. This is Gopal from Department of Chemistry, Bharathidhasanar Matric Higher Secondary School, Arakkonam. Today we are going to see 12th Chemistry, second unit. Topic is chemical properties of boron. So we already discussed about the boron family and the elements present in the boron family, in which the first element in the boron family is boron. So only is named as the boron family. So in boron family we see the chemical properties for the boron element. What are the chemical properties? Let's see here. At first, in the boron group, the one and only non-metal is boron, because the other metals, aluminum, gallium, indium, thallium, these types of elements are metals or metalloids, but only non-metal is boron in group 13, and boron reactivity is very less, because the boron is not a metal. Metals only can able to donate the electrons, so they can involve in the reactions in very reactivity, but the boron has less reactivity due to its non-metallic character, but even at a high temperature it can react with high reactivity. And boron's third property is it can form electron deficient type of compounds. So already we seen about the boron compounds, diboron, borax, so that type of compounds contains electron deficient character. So due to its electron deficient character, it can able to form the covalent bonds. Why the covalent bonds are formed? We already know that the properties of p block elements contains the elements in smaller. So size of the element is smaller in size. And they have high electronegativity. High electronegativity. So that's the matter, students. Due to the p block elements character, the small size elements and high electronegativity elements, so that the boron also have the same properties, it can form covalent bond. So this character helps to boron to make a covalent bond. Boron, not only boron, with the boron, carbon, hydrogen also have similar electronegativity values, similar electronegativity. So the electronegativity when compared to the carbon, hydrogen, boron, they are similar. So you can mind it and you can use it for the 1 marks also. The electronegativity values in order to boron, carbon, hydrogen means you can write it. It will be similar. How can you write the similars? Boron similar to carbon, similar to hydrogen. So similar can be written as this type of symbol. These are the character of boron element. So how it involved in the chemical reactions? Let me see the first reaction. Let's see. First, boron forms borides, mainly metal borides. Boron when combined with the metal atoms, it can form metal borides. So first we take one reaction with chromium, Cr. The symbol for chromium is Cr. When reacts with boron, it can form CrBn. CrBn. So why we write N? Because N may be the values 1, 2, 3. So number of borons it may be differ, but chromium generally forms chromium borides. We see metal borides, so it is called as chromium boride. Its name is chromium boride. Let's see the spelling: CHROMIUM and boride, BORIDE. Likewise, we can also prepare the another metal boride tungsten boride. The tungsten boride formula is WB. You know well, the tungsten symbol is W. So when tungsten boride is formed, it will only occurs in 1500 Kelvin temperature. Also, all the metal borides are formed in at higher temperature 1500 Kelvin. So how much degree Celsius is this? You can find the degree Celsius by subtracting the value 273, because at 0 degree Celsius the Kelvin value is 273. So we can convert it into degree Celsius. 10 minus 3, 7, 9 minus 7, 2, and remaining 14 minus 2, 12. So 1227 degree Celsius. When comparing this, it is very higher temperature. It is the melting temperature of the metal. So at this melting temperature only it is formed boron trihalide. Boron trihalide. How it is formed from boron trihalide? Let's consider any boron trihalide. For example, I take BF3, boron trifluoride. When boron trifluoride reacts with sodium hydride, then only it forms the tungsten metal. Let's see this reaction. I write this reaction again. So the temperature is 1227 degrees Celsius. So this is very higher temperature. This is the melting temperature of the metals. So at a higher temperature only boron can form metal borides. So boron reacts with tungsten, you know. So we take tungsten metal W. We take tungsten metal as WCl, tungsten chloride, when it reacts with boron B. Let's see, at higher temperature the metal gets reduction. Reduction means it only takes in presence of hydrogen. So when hydrogen meets the chlorine, it intakes the chlorine and forms HCl. The remaining chlorine molecules can be eliminated into Cl2. So what is the formula for tungsten chloride? Tungsten removes the Cl2 chlorine molecule and also donate one chlorine to hydrogen. So total number of chlorine is 3, WCl3. When reacts with boron, it forms tungsten boride and HCl plus Cl2. So this is the formation of metal boride. Likewise, we can see the next reaction. Let's see, students. Likewise, the metal borides in various types also formed. Chromium boride, osmium boride, rhenium boride, ruthenium boride, molybdenum boride. Likewise, different metal borides are formed in different formula. Chromium boride can take CrB2 generally and OSB2 osmium boride, ReB2 rhenium boride, Ru2B3 ruthenium boride, MO2B4 molybdenum boride. Likewise, metal borides are formed in different reactions. So in this video you studied about the metal borides. And okay students, the next one, formation of hydride. When boron reacts with hydrogen, then only it forms hydride. How much boron will react with hydrogen? Once again, boron reacts with hydrogen to form boron hydride. How much boron can react with hydrogen? 2 boron can react with 6 hydrogen to form diborane. So this molecular name is diborane. When diborane is formed means boron must react with hydrogen. Okay. So you take the boron and for hydrogen you can take sodium hydride. Sodium reacts with hydrogen to form sodium hydride. It is used for hydrogen. The reaction takes place at 450 Kelvin and it can form sodium. Want to remove, sodium also want to remove with the halogens. So boron want to come with the halogens. So that purpose we first reacts the boron with the halogen. Boron when combined with the halogen, it can form boron trihalides BX3. Generally halogen atoms fluorine, chlorine, bromine, iodine will be present in as a double atoms. So X2, it may be Cl2. So we balance the equation by 2BX3 is formed by 3X2 and reacts with 2 borons. This boron trihalide is taken for this reaction BX3. So the X3, 3 halogens is removed with the sodium NaX. It may be NaCl like that. Let's consider to balance this equation. You see 6 hydrogens in the product. So before hydrogen I write the number 6 and 6 sodium can eliminate 6 NaX. So 6 halogens means here I want to write 2x3, totally 6 halogens. So the equation is balanced. This is the correct balanced equation. Formation of hydrates is not directly from boron. It want to formed from the boron trihalides. So you note it, from boron trihalide we want to prepare. First we want to prepare the boron trihalide by reacts with boron with the halogens. And next one, formation of boron trihalide. How can we form formation of boron trihalide? This reaction you can write. When 2 boron reacts with 3 halogen molecules, it can form 2BX3. For halogens purpose, you can use the chlorine also. 2 boron reacts with 3 Cl2, you can form 2 boron trichloride. So this is the reaction. So boron's chemical property as it forms hydrate and how it reacts with the halogens also referred here. We can go to the next reaction of boron. Boron nitride. Boron nitride is very easy because one boron reacts with one nitrogen. You know the boron reacts with 3 halogens. Nitrogen also reacts with 3 hydrogens, So valency of boron and nitrogen are same. So one boron only reacts with one nitrogen to form boron nitride. Valency of boron and nitrogen is same. So one boron, one nitrogen only can form the molecule. But the boron and nitrogen, let's see, nitrogen is the double atom. So nitrogen will present as a molecule N2. So N2 can form 2 boron nitride. To prepare 2 boron nitride, you take 2 borons. So this is the correct balanced equation. The formula contains the name boron nitride. Same like the oxides of boron also easy. Boron oxides. Boron generally forms boron oxide as boron trioxide B2O3. You can write it as boron oxide or boron trioxide, both are right. Now I write boron oxide as it. When boron reacts with oxygen, then only it form boron trioxide. Let's note one point. These reactions only occur at higher temperature. So heating is essential. At high temperature, then only it forms. So boron reacts with oxygen to form boron trioxide, in which oxygen is the double atom. It's a double atom containing diatomic molecule. You don't get diatomic molecule. So to balance this, I take 2 borons, then only borons is balanced. 3 oxygen. Here 2 oxygen. To balance this, I take 2 into 3 formula. So here I write 2 into 3, here I write 3 into 2. Totally 6 oxygen is balanced. This is the correct balanced reaction of formation of oxides. So boron oxide also formed. Are you clear? Good. So from this video, you've seen various chemical properties of boron, By this, I ask one question. Which metal can combine with boron to form metal boride? So, let's consider the reaction. When tungsten reacts with the boron, it forms the tungsten boride. So, remember that reaction. So, tungsten also reacts with the boron. And next one, chromium. When chromium reacts with boron, it can form CrBn, chromium boron. Generally, it will be CrB2, chromium diboride, chromium boride, metal boride, you know. So, tungsten and chromium both are involved in the reaction. So, option C, both A and B is the correct answer. Are you clear? Good students. Good students, in the below description, you have the study material and self-assessment question paper. Just refer the study material and you can write the self-assessment for your own clearation. If you have any doubt, you can ask me immediately. Thanks for making time to watching this video. Thank you.